Hello, this is going to be a short introductory video into binary. I'm going to start though by having a quick recap on decimal and the things that we know about decimal. So under my decimal system, I can use the digits 0, 1, 2, 3, all the way up to 9. So I've got 1 to 9 plus my 0 gives me 10 different digits that I can use. That's one of the reasons why we call it base 10. Got 10 different digits I can use. So I want to count up to 9. I can do that using my existing digits. As soon as I get to the number 10, I have to start thinking about my place value. So we know under our place value that the first column are my ones. So I can put my 0 to 9 in here and I'm all good. As soon as I get to the next number, number 10, that's when I start needing the next column over. My 10s, I'd have a 1 in this column, 0 my ones, and I've got the number 10. So my other place values, I've got my 1, I've got my 10, my 100, my 1000, and my 10,000. So what I've done is I've taken my number 10, which is the number of digits I've got, and I'm raising it to a different power. So let me write those on. So I've got, I'm going to come back to 10 to the 0. Next column, I've got 10 to the 1, so 10 to the power of 1 is 10. 10 squared is 100. 10 cubed is 1000. 10 to the power of 4 is 10,000, and so on. I can keep going as far as I need over to the left-hand side. Remember, anything raised to the power of 0 just has the value of 1. So 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4. So my base doesn't change. My base is 10 in each case. This is why we call it base 10. So 0, the thing that's changing is my power. It goes up by 1 each time. So I've gone from 0, 1, 2, 3, and 4 for each of my columns. So my next column over would be 10 to the power of 5, which would be 100,000. And with that, I can work out any number. I know that I've got 7 in that column. That's worth 1,000. So I've got 7 times 1,000. I've got 3 times 100. And I've got 4 lots of 10, and I've got 2 lots of 1. So I've got 7,342. 7,342. I need to remember my place values, otherwise my number's going to change. Right, let's have a look at binary. This time I am stuck with the digits 0 and 1. Off or on, sometimes we think about it in computing terms. I can't use anything else. So if I look at my first column, my number 0, well that's just 0. If I want to write my number 1, I can write 1. As soon as I get to 2, I've run out of digits. I can't write that number 2. The 2's not allowed. So I can't write 2. So I have to start using my place value. So the number 2 is the same as a 1 in the 2's column. Well, I've got 1 lot of 2. And, well, to get to 2, I'm already at 2, so I need a 0 lots of 1. I still, in the same way that I need my 0 up here to represent 10, I need the 0 next to my 1 here. Otherwise, this, rather than being 1 lot of 2, becomes 1 lot of 1. So I need this 0. So 1, 0 means 1 lot of 2 plus no lots of 1. Got the value 2. Have a look at what each of my place values are worth in my binary. So my first column is 2 to the 0. Remember, anything to the power of 0 is 1. So 2 to the 0 is 1. I've got 2 to the power of 1. 2 to the power of 1 is 2. I've got 2 to the power of 2, which is 4. I've got 2 to the power of 3, so 2 cubed is 8. 2 to the power of 4 is 16. And 2 to the power of 5 is 32. So I'm doubling up my numbers each time. So the place value of each of those columns goes from 1, double to 2, double to 4, double to 8, double to 16, double to 32. So I've got this time all of my numbers, the base of these numbers is, so the base is the number at the bottom, so this number here. So the base of each of these numbers is 2. It's one of the other reasons why we call binary base 2. So base 10 This number at the bottom is my base. Base 10 doesn't change. Binary, base 2. Got this 2 at the bottom. My powers, just like with my decimals, increase by 1 each time. So I've got 0, 1, 2, 3, 4, 5. So let's have a look at some examples. It's actually normally easier to go from binary to decimal than it is the other way around. So if I've got a number 1001 in binary, first thing that I want to do is to write my place values above each of the positions. So I've got first column's worth 1, second column's worth 2, third column's worth 4, and the fourth column's worth 8, then 16 and 32. So for this number, I've got one lot of 8. Well, 1 times 8, I can do that. I've got no 4s, no 2s, but I've got 1 1. So I've got 8 plus 1, and that's, shift you over a little bit, that's equal to 9. The next number, I've got 10101, so I've got 116, I've got no 8s, I've got 1 4, so 16 plus 4, I've got no 2s, and I've got 1 1. So I can write that down as plus 1. So I've got 16 plus 4, 20 plus 1, and that's equal to 21. Next number is getting a little bit bigger. So this time I've got one lot of 32. I've got no 16s, no 8s, no 4s, but I've got 1, 2, and I've got 1, 1. So I've got 32 plus 2 is 34 plus 1 is equal to 35. The benefit of binary is that the multiplication is always going to be quite straightforward. You're just going to be multiplying by 0 or 1. So you're either going to end up with a 32 or no 32s. I'm going to end up with no 16s, no 8s, no 4s. The multiplications are either ever going to be 0 or 1. The downside is these numbers get very big. So this is the number 35. So write it in decimal, I've got 2 columns, 3 10s and 5 1s. But to write it in binary, I need 1, 2, 3, 4, 5, 6 columns to get to the same number. So the number of digits over here get very large very quickly. But all you need to do is write your values. So remember, if I've got some more digits over here, I'd just be doubling up. This would be 64, 128, 256, 512, 1024, just doubling up each time, and then working out, in this case I've got one lot of 32, one lot of 2, one lot of 1, and then just add them up. So this is worth the number 35. Right, let's go back to the table, working the other way. So if I've got my decimal numbers down here, and I want to convert them into binary. So we worked out that 2, I needed one lot of 2, and no 1s. This is worth the value 2. To get to 3, I'm looking for the biggest number along here that's going to divide into 3. Well, 2 will go in. 4's too big, so I don't need anything above 4. But I need 1, 2, and then I still need an extra 1 to make myself up to 3. So I've got 1, 2. If I put a 1 in my 1s column, so I've got one lot of 2, one lot of 1, that's given me a total of 3. 2 plus 1 is equal to 3. Moving up to my next number 4, well, I want the biggest number that's going to divide into 4. So 8's too big, so I don't need any 8s or 16s or 32s, but I do need a 4. If I put the 4 in, then I'm actually already there, because I've got one lot of 4 is equal to 4, and I'm finished. But I must remember to write my place values in, my 2 zeros, because if I haven't written those in, then I'm back to 1, 1. I haven't got 1, I've got one lot of 4. So 1, 0, 0 is equal to 4. 5, I do the same thing. What's the biggest number that divides into 5? Well, it's going to be my 4, but I'm going to be left with 1 over. That's equal to 4. Still got 1 to place, so I don't need any 2s, but I do need a 1. Number 6, again, 8's still too big, so the biggest number I can use is my 4, so I want one of those. What have I used so far? I've used my 4 up. One lot of 4. I've got 2 still to go. So if I start with 6 and I've used 4, I've still got 2 to place. Where's that going to go then? It's going to go into my 2's column. I can fit one of those in. So I want 1, 2, and then I don't need any 1s. So I've got 1, 4, 1, 2, 4 plus 2 is 6. All good. Next one, 7. Still can't fit an 8 in, but I can fit a 4. So I start with 7, I've used a 4, I'm left with 3. I can fit a 2 in, and that leaves me 1. So I need to put a 1 in my final column as well. So I've got 1, 4, 1, 2, and 1, 1, and that's my 7. Well, as soon as I get to this stage, I've used all my 1s. I know I'm going to count. I'm going to tick over into my next column. So next number down is 8. So I can now fit an 8 in. I still can't fit a 16 or a 32, but I can fit an 8 in. So I need one of those. 8. I've used them all up. So I have no 4s, no 2s, and no 1s. I just need a 1 in my 8's column. 8 is 1, 0, 0, 0. As soon as you get that line of 1s, you know your next value is going to be one column over and then a bunch of zeros. It's like having 999. You tick over to 1,000, you move over to the next column, you end up with 3 zeros. Let's have a look at a bigger number this time. So I've made a bit of a jump, and I've now got the number 20. So I'm going to look for the biggest number that's going to fit into my 20. 32 is too big, but 16 will fit. So I need one lot of 16. So I'm going to put a 1 down here. Take 16 away from my 20. That's going to leave me 4. I still need to put 4 into my other columns. So 8 won't fit, so let's put a 0 in. But I can put a 4 over here. 4 will fit, and I'm down to 0. I've used all my numbers up. So I just then need to remember my two placeholder values of 0. So I've got 1 16, I've got 1 4, and that gives me my 20 that I'm looking for. Last example, 19. Well, again, 32 is going to be too big, way too big. 16 is going to work though. I am going to need to use one of my 16s. So let's bring it down. We've got, so I'm starting with 19. I've got my 16 there already. So that's going to leave me 3. So the 8's not going to fit, the 4's not going to fit, but I am going to need a 2. So no 8's, no 4's. I'm going to need 1, 2. That leaves me 1 still to place. That's my 1 in my final column. So I've got 1 16, I've got 1 2, and I've got 1 1. 16 plus 2 is 18 plus 1 is equal to my 19. Okay, give the questions a go. Hopefully that makes a little bit more sense.